Okay, so sustainability, no surprise, is perhaps, if not certainly the number one focus for the data center industry at the current time. And I guess there are the obvious strand is innovation technology wise, there's a lot going on. But is there also a suggestion that when it comes to environmental reporting, the way that data centers, say what they're doing at the moment, it's perhaps difficult because they, not always, comparing apples with apples, if you like, etc. Is there a need for more, and is that coming in terms of understanding what people are actually doing rather than what they're telling you they're doing, if that makes sense?
The answer is absolutely yes. So if you look at the sustainability aspects and the financial reporting, so do we need regulations and reporting? Yes. Is it coming? Absolutely. And it started, coming up right now. You look in Europe, the regulations that were passed, corporate responsibility, corporate disclosure for responsibility and governance, I think CDSR, sorry, I'm bad with acronyms, but essentially requiring the data collection for various KPIs starting January 1st, 2024. You look at SB 253 in California, which is the trendsetter for the industry, looking at the carbon impact for infrastructure. So how do you look at sustainability, and how are executives in various companies looking at sustainability? It depends on who you're talking to, right? So sustainability, if you look at it at its core, has three pillars. Right, you have the economic performance, you have the reducing the environmental impact, and enhancing social equity. And the industry right now is talking about various things around sustainability. Number one, to your point, Philip, do we need more disclosure? The answer is yes. The question is, what are we measuring? Right? Most of the discussions right now have been around, give me your power utilization effectiveness, and how are you measuring that, or carbon CUE, or carbon utilization effectiveness, or water utilization effectiveness. And the focus has been around, we have, as of 2022, 7 million data centers globally, 105 gigawatt of power built, right? Almost 600 of terawatt hour of consumption. Right. The question is now, what are we building 2024? Hyperscalers are looking at 20,000 megawatts, 20 gigawatts of power. AI is going to have an increase of possibly 35 gigawatts, and we're not even scratching the surface. So when you're talking about sustainability in that context, is it only just measuring the carbon impact, which I will take a deeper dive into in a second, but also you need to look at it from an economic performance. And I'll give you this example. And there's a industry pioneer and a leader, Dean Nelson, talks about this a lot as part of the iMasons and the Climate Accord. It talks about, like, if you have a data center built out for 100 megawatts, right? The current traditional model, the way the industry works and has worked and generated billions and trillions of dollars of profits, is I build a data center, I get people to come in, I allocate power. I allocated almost 100 megawatts. I go build another data center. I have my cash flow. My cash flow model works. Again, the economic performance, the first one, right? And now I go build another data center. And we're building in the tier 1 cities. And then now we're expanding into the edge, into various tier 2 and tier 3 locations, and so on and so forth. The model works because we're generating money from it. Now, the question is, out of that 100 megawatts, how much is actually used? Typically it's sub 60%. So the question is, why are we going to build new data centers, although we can actually reuse the existing capacity? So we're doing that. We've been doing that for network. Think about your broadband. We build it, if it's a cable or fiber, you put big channels and you subscribe a lot of people subscribe to it, and then you end up utilizing it, and there's oversubscription. We do that for storage. We do that for compute. That's the cloud model. Why aren't we doing that for power? The impact of that becomes, I defer my capital allocation for several years out. I don't need to go build a data center. And remember, every megawatt of power is $5 to $7 million in normal times. Post-COVID, slightly higher, right? So when you start looking at sustainability, it's a positive feedback loop. You enhance the economic performance, you reduce the environmental impact, you enhance the social equity. Now, we've been on a train where We need more capacity, go build it. Virginia, we're less than what, 1% of power available, but really we have more than 40% available. If you start looking at the right metrics. So to your first point, do we need to publish metrics and start looking at KPIs correctly? The answer is yes, but which KPIs? The industry has been focused on the traditional KPIs. My power utilization effectiveness, I wanted to reduce it from 1.6 to 1.1, which is, Google achieved that. That gives you an additional lift of 40%. Power utilization effectiveness is, this is the total power I'm using, and this is the IT workload, divide the IT workload divided by that. I'm optimized. But that can be cheated. How can you cheat it? I was actually talking to in an industry conference 2 weeks ago, and said, put heaters in your data center. Heaters consume power, a lot of power. You increase the utilization, and then what happens? Your PUE is better. But are you enhancing reducing the environmental impact? The answer is no. So bringing it back to your question, sustainability. It is the forefront of the discussions right now. How can the industry start publishing metrics around the available capacity and start looking at the capacity in a more meaningful manner, whereby we start looking at how do we optimize the economic benefit by deferring CapEx deployment, but as well as enhancing the financial benefits and financial outcome of a data center. The impact of that also reduces the environmental impact, because every time you build, you have carbon emissions, you have carbon costs for building, you have using more power allocation, and so on and so forth. So the second piece of this is from an operator perspective. And the second hat I would wear is from somebody who's running the IT workloads, or somebody who's consuming that. A lot of discussions have been about targets, right? My 2023 targets are X, right? My carbon impact target, or zero targets, net carbon impact zero is Y. But I optimistically, I hope that this is aspirational, but I believe at my core, it's the worst case scenario. This is all BS. And the reason I believe it's BS is, if you think about IT refreshes every 2 to 3 years, you have a refresh cycle. So we have maximum 2 refresh cycles by 2030. The more impactful, and if you think about a trajectory for carbon emissions, if you do the change earlier, it's smaller, but it's more impactful. So our executives, our operators, our leaders looking at this in the right manner? And I doubt it. And the reason is, everybody's thinking I can build, or not everybody, I said the majority are thinking I can buy offsets because it's too hard. The answer is no, it's not too hard. It's actually, you need to ask the right questions. And for measuring the carbon impact, which I think where the regulations are heading towards, is looking at the 3 fundamental questions. Where am I hosted? That impacts my carbon impact, because that's the source of power. Is it hydro? Is it carbon? Is it nuclear? And so on and so forth. How am I hosted? That's within my control. What kind of gear am I running? What is the compute utilization on that? Am I running at 10% and I have 1 million servers, or I'm running at 80% and I have 1,000 servers? Am I optimized from that perspective, right? And I have energy efficient servers, virtualization, so on and so forth. And then what am I sourcing? So that gives you the scope 2 and scope 3. Scope 2 is what am I consuming? Scope 3, what am I sourcing? The challenge has been, how do you pull all that information together? So, and I'll end with this around sustainability. If you think about sustainability as various roles in the organization, think about the C-level as a driver. The C-level always looks forward, looking at 2030 and saying, am I gonna hit my destination? I'm gonna reach my destination on time and on budget. So think about it. You need a GPS that gives you where am I hosted? How am I hosted, and what am I sourcing, right? And be able to navigate like as if you're having a GPS. The second level of management is looking at more at KPIs from an operational perspective and capacity. So you think about, you're looking at your speedometer and you're looking at your rear view mirror to look at what happened. right? Am I looking at metrics around PUE, data center infrastructure efficiency, where I'm looking at how much am I using to what I committed to. I subscribe to 100 watts or kilowatts, and I'm using 10. Is that efficient? No. So the right metrics, right? I'm looking at what type of assets, what they're using, security-wise, and so on and so forth. And the third tier is more the hands-on. What servers do I need to tackle? What rack am I running out of capacity and overheating? What so on and so forth. That has been missing until recently, where companies have been focusing on providing and pulling all that information to the various stakeholders. So in summary, regulations are needed, and regulations are coming, and it's going to be a cost like similar to sales tax or VAT or anything in terms of considering the cost. The compliance aspect will be tremendous because you need to provide evidence you're running. But the fundamental question would be, what are we measuring? If you're only looking at PUE alone, it's a false measure. PUE is one of the inputs. PCE, power capacity effectiveness, again, I refer to Dean Nelson. He has a lot of articles about that as part of the iMasons and all that, talking about total power consumed divided by total capacity is important. Data center infrastructure efficiency is important from a user perspective, right? And then you can go down the metrics depending on the persona. And tracking that and creating thresholds and insight what to use. So yes, regulations are coming. Sorry, I had a lot of coffee today.
I'm also just interested. I mean, obviously regulations are coming, but do you think the scene you've described is the appetite there to when they arrive to sort of embrace them and work positively with them, or as you suggested earlier, people are happy to buy carbon offsets? Do you think a certain percentage of people will still kind of think it's worthwhile trying to cheat the system in inverted commas rather than go, yeah, okay, we understand what we've got to do, and we will willingly work towards that?
Well, it's both. So how do you drive change? Either through education or you tell somebody you have to do it. The industry has been profitable for years and years and years and drove innovation in various development in various sectors. But we're running out of land. We're running out of resources. We have supply chain delays. The grid can't sustain the demand. So the industry now is pre-buying power and commit so they can provide funding to utility companies that are publicly regulated. To do that, they're looking at hydrogen power data centers. They're looking at microgrids to avoid some of the regulations around utilities and all that. So you start looking at it and ask the fundamental human question: do you know how people move? Look at how they're incentivized. As it gets more costly to deploy infrastructure because we're not making more land, then you start looking at like, how can I optimize that? So you're gonna have some appetite to say, well, to make sure I maintain my own returns, I need to start measuring the right KPIs and reporting it. So somebody who has multiple gigawatts of power under capacity, they start looking at it as like, okay, now I need my PUE to be closer to 1.1. I need my PCE to be as close as possible to 1, because it doesn't make sense to build a 100 megawatt data center allocated to customers, and they're although I'm making money out of it at the allocation, but they're using 20% of that because I have to go build another data center. Versus now I can look at oversubscribing the power. I'm fulfilling my contractual obligations, but yet I'm making more money out of that data center. So it's really embracing the innovation that we drove, and we as an industry have been talking about it with the industry that drives innovation, but with a lot, we're very slow in adopting innovation. So the appetite is there. The more you participate in industry conferences, the more you see the industry leaders and masons are talking about what needs to change, because it's getting harder and harder. And what is interesting and encouraging, I would say, about this is you're seeing the discussion from the supply chain you're seeing the industry, and from the consumption side and from the enterprise side. The operators are talking about, okay, so I need now to go deploy more capital to buy more land. Supply chain is strained. You're looking 18 months, sometimes delivery timelines, and so on and so forth. How can we think differently about this? So regulations, it's a carrot and a stick, but the incentive is there because you want to know how people move. Look at how they're incentivized. This will increase the returns. And again, it's one of the pillars of the sustainability aspect, is enhancing the economic performance. So there is appetite, yes.
Yeah, and I was going to ask this later, but it probably is a good time to ask now around data center locations. So it's no secret the Nordics, for example, there's a lot of activity there. You mentioned obviously you got your sort of tier one, the flap hub, etc. in Europe. You've then got tier twos and stuff. I'm just curious as to how you see, with perhaps sustainability in mind, how data center locations might change, or at least the emphasis might change. Yeah, clearly the capital cities, financial hubs will always be important, but outside of those, do you think we'll see increasing activity, shall we say, in further north, further south, because of the climate conditions, the renewable energy resources? Is that likely to happen, or will the imperative of always having your data center within sort of touching distance override that type of activity?
Well, it depends on the workload, Philip. So if you think about the change that has happened to the industry from, if you look at, take a snapshot of 2000, right, versus the expectation by 2025. In 2000, almost everybody was running on-prem data centers and enterprise data centers. By 2025, the expectation is about 20% will be on-prem. Think about it, these are the legacy workloads and mainframes and applications that cannot move, period. Like, it is more costly to redesign these to move them. 30% will be in public cloud, and then the rest will be edge. And what is the definition of edge? Edge data centers are, think about it, where compute, storage, and network is as close as possible to where the data is, right? Think about smart agriculture. You have autonomous driving and sensors for pesticides, chemicals, water, hydration, and so on and so forth. The value of the data is to be close as possible to the operations in these rural areas, because broadband is very hard to get there, and so on and so forth. And then that data gets analyzed and used, and while operating those autonomous vehicles or smart ag, and then you can ship that later to think about it as an aggregation, as a cloud, right? So think about it, you have big data centers that cloud lives in, and then you have edge data centers where workloads reside. Think about autonomous driving, think about smart cities, think about healthcare, and so on and so forth. You need the decision making as close as possible to where the data is generated, but then that data can be then transported to big data centers. So that means that as you think about the expansion will be more in the edge, and then you think about expansion up north is probably more for aggregation and processing. But when you look at that as well, you need to start looking at it from what complexities are around that. So the carbon impact is one, data residency is another, right? Like, are you shipping information for EU residents or EU to the US or somewhere else? You can't. So there are regulations and restrictions around where data can be transported and what kind of data can be transported. So you'll see expansion in both. USP, definitely. And with AI, AI is prevalent and will continue to be prevalent, and that will drive a lot of demand as well.
And just on the location before moving on, do you think, geopolitics, clearly very difficult to anticipate, what crises might crop up where, but is there any issues with where people build data centers, or do people need to be slightly more thoughtful because of the instability of the political environment, or is that not particularly an issue for people to think about?
Oh, of course it is. And you think about the various continents and infrastructure, and I think the iMasons we're going to publish a report, or they have published a report about this. What we saw with India several years ago, there were several, 100 megawatts of power only deployed as data centers, and now they have like 1.2 gigawatt, I think, under development, and they're just ramping up. Africa has less than 300 or 350 megawatts of power for the whole continent. So demand will drive expansion. So that's an area for expansion and all that. But as well as in North America and Europe, where you have a good chunk of the 7 million data centers that have been deployed, there's insatiable demand. Like you think about all the devices that we use generate, massive amount of data, but then AI is exponential in terms of growth. So that's driving a lot of demand. You think about the hyperscalers in 2024, they're doing 20,000 megawatt of data center capacity, like 20 gigs of power. That's substantial. And that's both for cloud and for AI. And you look at the latest stats of adoption of GPUs from NVIDIA. I think Meta was 150,000 GPUs, Microsoft 150,000 GPUs, and the tier down is 50,000 GPUs. These are powerful graphical processing units that require a lot of power, and the capacity per rack and all that is being, denser racks, more power per rack, liquid cooling, and a lot of innovation around that to make it that way. But that would require data center capacity. So geopolitics is one of it. Demand is another, for sure. And you need to be thoughtful about geopolitics, because the bigger the data center, the bigger the loss if it gets damaged. So you need to think about redundancy and so on and so forth.
Yeah, and you mentioned AI a couple of times, so let's talk about, I won't say it's the elephant in the room, but I mean, it's anticipated the impact of it's going to be bigger than, cloud virtualization, so, and we've talked about sustainability. In theory, building a whole load of new data centers, as you say, your high density, massive new power requirement doesn't sound very sustainable, but everyone's talking about this AI juggernaut coming. So how do we square that circle of even more data center power required, capacity, etc., but we're all supposed to be also working towards net zero? How does that work?
Well, it's the same formula. It's that positive feedback loop, optimizing the economic performance of your data center and infrastructure, understanding what we have. We have massive capacity deployed right now. So what is the potential of optimization there? So if I take the PUE on average, I think in the US in 2022 was 1.58, right? The impact of AI is, okay, how can I reduce it to 1.1? That gives me 40% of the capacity back. And that is an active discussion right now. Then the second piece is, can we oversubscribe power? Can we look at the industry metrics around PCE, power capacity effectiveness? And the answer is yes, we can. We're doing it for every other resource that we use as human beings in technology. So we should. And so with that frees up capacity that you don't need to go build new data centers to have capacity. That reduces, I shouldn't say does not need, but that would reduces the amount of new builds that are required. And it's a balancing act for sure, because power is going to become more expensive as you deploy more capacity in the utilities. That capex needs to be recouped, and that investment. So nobody's expecting the 7 cents per kilowatt to be maintained in some jurisdictions, right? So some are paying 12, 15, 20, and some depending on where you are in the States. It is going to drive demand, but it is a positive feedback loop where you optimize one, you keep optimizing, and it's a continuous. I recently started talking about data centers akin to the human beings. It's continuously, so many things are moving, and the brain keeps us in a state of hemostasis where it processes all that and keeps adjusting. And the same with data centers. That level of automation, orchestration, and monitoring will drive efficiency by using AIs to optimize data centers. That's the funny part of it, which is good.
Yeah, and to that point, skills is another area or skills shortage, to be more accurate, is another industry potential crisis. And I know that AI is put forward as a part of the solution to that. But I suppose in simple terms, does AI or is AI able to make up the shortfall of the skilled individuals we don't have, and with the age profile of the industry, a lot more people potentially going to be lost? Or do we need to worry slightly that there aren't going to be enough people? Or, as I say, the lights out AI controlled data center talked about, it's probably, the hyperscalers probably have it somewhere, but will it become, very much the standard for the industry, or we'll still need quite a lot of well-trained people?
Yeah, I think you're in touch with the vibe in the industry and what the industry is talking about right now. So this is awesome. So one of the key challenges for the industry is recruiting and retaining talent. So if you think about the current generation, and I'm sorry, I don't remember the stats in my head right now, but I know the majority of people who operate data centers inside the data centers are close to, the retiring age. I think in the next 10, 15 years. And the challenge for the industry has been recruiting the younger generations. And 2 weeks ago at that conference, we were talking about that. And my opinion on this was, we're asking new talent. We're trying to recruit them from universities and others to go work in a big concrete block that we build in a remote location, where the only thing that they do is interact with machines, and people are screaming at them to provision things fast, and there's an outage. And some of the tools that we are using are so manual that you start looking at the retention and the workloads for people. It's not sustainable. So the industry has been rethinking about this, and retooling is required. Now, is AI required there? AI is a big umbrella, right? And you think about the talent shortages. The first thing is, what is the responsibility of the team and the talent? And we talk about it at Hyperview in 3 S's. And we talk about the talent as and this is why I'm wearing this, as the guardians of the infrastructure. You think about COVID, the economy survived because of the guardians of the infrastructure. Without the digital infrastructure. So what do our guardians do every day? They wake up to secure the infrastructure. They wake up to sustain the infrastructure. And they need to streamline the operations. So for that, you start looking at what retooling is required. And we're starting to see that AI is required. For AI to be successful, think about AI in 2 big chunks: statistical models, machine learning, which will probably give you 90% of everything you need. That requires a structured monitoring pipeline. You think about all the data inputs back to the human being, your nervous system. You think about the facility layer, the IT layer, the network layer, all that. All that needs to be ingested, monitored, and structured so to enable those models, right? That's an area that we're seeing companies looking at and saying, okay, I need to retool to drive that single pane of glass. And I'm having those discussions on daily basis, literally on daily basis. And which is awesome to see. Once you have that monitoring pipeline feeding statistical models, you can go, up the stack in the insight level. Descriptive, I know what I have. Diagnostic, what happened. Predictive, can you tell me if it's going to happen? And prescriptive, that's where a lot of failure analysis and security updates and so on and so forth. Second level of AI is more the transformer model. I take those statistical models and all that, then you need to think about training. Is it public, private, or personal? Probably more on the private side, the majority of the cases. Some you can ingest some things from a public side, like, for example, image recognition to what servers I have and so on and so forth, but predominantly private training. And then that you can tool the AI model to do some things. Example, hey, Jarvis or Siri or whatever you want to call the AI model affectionately, find me all the power distribution units that require updates, create the work orders for approval, click done. Today, people have to do scripts or physically go with USBs, right? So you think about the workload. So that's one technology. Another technology that people are looking at and the industry is looking at as RFID. RFID was extremely expensive before. Today, we work with customers. We integrated RFID strips or tags that are less than $2 that track the movement by rack unit. So the translation of that is you no longer have to print labels. You no longer have to do data inputs. You no longer have to do manual audits. So now you start looking at alleviation of workload. What is a person working in a data center doing? Now, 20% of the workload is removed because you're adopting technologies. Augmented reality is another aspect. You're looking at how can I reduce the travel of people by enabling augmented reality where I can access my data from my DCIM securely and have people collaborate and self-document. That is here. Like this is something that we work with customers on in collaboration with partners. You look at robots and drones. You think about today in the industry, and I think forget the name of the gentleman. I'm not going to plug the name of the company either, but one of the big data center operators was talking about they fly drones on daily basis to monitor and periodic and multiple times during the day to monitor heat zones above the data center to understand what is happening from the outside and from the inside. So you're talking about recruiting new generation drone technology, looking at robotics as well. All that is IoT as well, discovery, multi-protocol discovery. And then that leads into you have a very sustainable, a very rich, structured monitoring pipeline that pulls all that data. And then you start looking at the control pipeline and the analytics, and it becomes self-feeding. So talent shortages, we have a talent shortage. We can't recruit new talent unless we adopt new technologies that reduces the workload, because nobody wants to go work in a remote location in a big concrete block where the only consistent thing is people screaming at them to provision faster and deal with emergencies. So that's my take. And that's what we're seeing actually in the industry. In retooling to adopt newer technologies to satisfy the 3 S's. In our context, is secure, sustain, and streamline.
Okay, I mean, we covered a fair amount of ground. Are there any other sort of issues, challenges the industry faces that you think need highlighting as we head towards 2024, or have we covered the main ones?
I think it is exciting times for the industry. It is it's as exciting as the birth of the internet, to be honest. And with that comes challenges. With that comes we're gonna have a lot of oops moments, but as well as it's a moment where the industry is facing challenges, supply chain challenges, power efficiency, and I do believe, and I am confident in that we're having the right conversations led by a lot of the key peoples in the iMasons in the industry itself, and looking at the sustainability hopefully in the right way, and the 3 pillars of that. So what is life without challenges? So it's exciting times, and I'm confident we will conquer those challenges, and by working together and providing the right KPIs, I guess, and the right way to measure it.
Yeah, just maybe one final question. In terms of moving forwards, what you've described is quite a sort of changed landscape, which suggests that we've got to have something of a revolution with the industry traditionally, and understandably, because as you say, mission critical, uptime, those are the key performance indicators that are required. But if we're doing, so I won't call them risky things, but things that are taking people outside of their comfort zone, is there going to be a bit of a culture clash where maybe the younger people, comfortable with drones, AI, etc., and the older folks are going, well, hang about, if that's going to impact my server performance or reliability, whatever. So I'm just wondering, is the industry ready, or to be more revolutionary when it kind of tinkers around the edges and makes little improvements rather than a whole step change?
The reason I'm grinning and smiling is I think it's more an evolution than a revolution. We're not uprooting things. I think we're evolving. I think we're looking at it, and simplistically, I look at it, people, process, tools, measures, right? And this is a framework that when you look at change management, it is the most effective way to look at that. If you look at the workforce today and the retiring workforce and the workforce that is coming in, you're looking at ways to optimize. So we used to do it this way. We used to go, I'll give you one example, right? This is how the industry used to tag servers. You get a label maker, you go and say, here's the host name, and then the next you go, this is the PDU outlet, and then the next is another PDU outlet, and this is the IP, right? And you stick it. And that takes time to do. And then something changed, you need to go document that manually, right? And somebody has to do it. And if you don't, you have static stale data, right? So that's the old way. The new way is two ways. One, you can have an iPad or an iPhone that looks at your rack and uses AI to identify the server's model and brand and the rack elevation and update your DCIM, right? That's using AI, and now you shorten but then you have the label. What do you do with the label? Well, there are technologies like an RFID tag where you attach it once and you never have to print a label. So $2 for the lifetime of the server, and you can reuse it as well. So what happens? The new generation puts it, you never have to deal with 30% of the workload manually. That's an evolution, right? And as you start looking at what is my job as a manager, I have my 4 R's. I need to recruit the right people. I need to retain the right people. I need to retrain. I need to run the playbook, right? The 4 R's. So we're redefining the playbook like a sports team. Now, we used to do it this way. Doesn't work anymore because the volume. So how do you change it? So change is needed, and it will follow the same standard process that we used over the past centuries. People, process, tools, measures. And some will be slow to move. Some processes will be slow to move. Some processes will be fast to move. So depending on the process, right? I think about things in frameworks. So that's how I look at things. Yeah.
No, that's fantastic. As ever, it's been a joy to chat to you and some brilliant insights. So really appreciate your time. Thank you.
Likewise, Phil. I always appreciate the time. Happy holidays to you and yours, and to all the viewers as well.
And to you. And I'll look forward to speaking to you next year.
Likewise. Thank you.
Thanks.